This is a voice-activated LED soldering kit. I've had it for quite some time now, but they're super cheap and I would have added it to an order to make up the minimum order value. Nevertheless, I think it's going to be a really fun project to put together. So let's have a look at it now. Inside we have the main PCB. It's got silk screen on it, which is just as well because this kit doesn't come with any separate instructions. We also have our components, and these are in the same bag. Let's have a look and see what we get. So here's our microphone. We have 5 red LEDs. What's nice is we do actually have a power connector. We have the socket and the wire. We have a couple of electrolytic capacitors. This one's 1 microfarad and this one's 47 microfarad. We have a couple of transistors. A total of 3 resistors. And we'll check those values as we need to. And then a little scrap of paper here. And I think that was trying to tell us about one of the resistors, but it seems to have become disconnected. So that's a little confusing, but never mind. Okay, so let's actually start with our resistors and let's have a little look at what we have here. Okay, so these are a little hard to read on the blue coloration we have here. So let's double check them with a multimeter. So here's my budget multimeter. Let's have a little look and see what we've got. So this one I think should be the 10K. So let's go ahead and set this to, let's say 200, that'll do. And let's see if we have a 10K resistor here. And 9.8. Close enough for me. Let's have a look at this one. This one I think might be our 1 mega ohm resistor. So that would actually need to go on the next band up. And there we go. And this one looks to be our 4.7K resistor. So we can turn that one down to the 20 range. And there we go, 4.7. Okay, so now we've identified these, let's make sure we pop them in the right places. And as usual, I'm going to use my blue tack method to hold the components in place. Okay, I definitely cut this one a bit hard, so let's just touch it up to make sure that it's in a good shape. There we go. Okay, so what should we do next? Maybe we should do the transistors. I wouldn't usually do transistors next, but a lot of our other components are actually quite tall. I'm just going to trust that the outline here is correct for this particular component. And I'm not going to shape it, I'm just going to wiggle it in, pop it down as far as it will go. And that will do. Right, neither of those are particularly good, but just enough to tack the component in while we finish up the soldering job. So you should definitely mind your eyes to avoid pinging the leads everywhere like I just did. But there we go. Okay. Try and do the microphone next maybe. Let's have a little look, separate out these leads. So these are usually polarized, although I can't see any specific marking on this particular one. But if we look at the board here and we follow the outline, again, we will hope that's going to be correct. So I'm just going to pop that there. Just a dab of blue tack just while we solder that in. All right, I'm going to turn this soldering iron up a bit because as you might have seen, I've had a little bit of trouble getting anything to transfer the heat very well. I don't know if the temperature control works on this iron at all, let alone properly, but usually it's fine at around 315. And for whatever reason, I'm having trouble with this particular board. So let's see if 330 works better for me. Okay. Right. These capacitors are going to be kind of tall, so maybe I'll do those last, but then we can get on with the LEDs. Okay, and so on the LEDs, as normal, we can tell we have the positive lead by the longer lead. The negative lead has the short lead, but it also has a small flat section on the LED. And typically the positive has the smaller section inside the LED. And I don't know if you can see that there, but the anvil is usually connected to the negative. So the larger section looks like an anvil, is usually on the negative. Now there are some LEDs that don't follow these conventions. There are some LEDs, for example, with the flap side on one of the other edges, which is a bit weird. So do check your datasheet, but this is this standard convention for making LEDs. So in this case, electricity flows from positive to negative. So we need to make sure we put our LEDs in around the right way. And that, of course, is conventional current I'm referring to there. But what's interesting is they've marked sort of a flat edge on each of these LED markings as well, which lines up with the flat edge on the circuit, on the LED component. So we can slot these in positive to negative, and it follows the direction of the arrow. So I'm going to go ahead and pop all of these in. Okay, I'm going to put the connector in here now because I want to get it in before I put the capacitors in, which is going to make it hard to stick it down. I was going to do it last, just because it's plastic, and I usually do those kind of connectory parts last. But I suppose this time we will do it in this order. There we go, not too bad. Okay. So this is the 47 microfarad capacitor. So this one, again, goes in here. And we can see that this pin is negative, and we can see it on the other side of the board going down in this, yeah, going across here, down and round. So negative, we can work out, is the hashed section, although if we look very carefully, because there's actually a tiny plus sign as well. And so the negative is marked on here, but not the positive. So I always think that's a bit weird about the capacitors. Same game though, in that the longer lead is positive, the shorter lead is negative. And we put the long lead in the positive hole and the short lead down like so. Now what's interesting about this is if you look on the connections on this side here, there's actually no connection on the positive lead at all. So this capacitor actually won't be doing anything. But nonetheless, I am going to solder it in as shown here. I suspect it's just a smoothing capacitor for the power supply, or that was the intent, but it seems to have not been connected in the final circuit. And then again, same game here with this one. Negative is the shorter lead, negative is the hashed area, and we have the positive sign as well. So plenty of indications to make sure we get these around the right way. So let's hope we are. Now this one is connected on 2 different tracks, so that's good. This one actually is doing something, but we could probably leave the other one out. I'm not going to, because we might as well use it. Okay, so that's actually everything done. We actually have a power cable here, which is nice, so we can plug this in here. And I have a power supply just out of view. So if I go ahead and grab the crocodile clips here, or alligator clips if you prefer. So make sure that's like so. Should move the solder out of the way. Don't want to short anything out. And just pop this one in here. So I've not turned this on yet. Just gonna do that. Make sure that they don't short out. And I'm going to put this on 3 volts to start with, and we can turn this on. And everything's lit up. And there we go. It's now working. I'm not quite sure why we had a little bit of a glitch there to start with. But as you can see, as I speak, the LEDs now flash. If I tap the microphone, we get nice bright LEDs. But it seems to be working correctly. In this case, all this circuit's doing is it's using the 2 transistors to amplify the voice, which is triggering and turning on the LEDs. As I say, this capacitor doesn't seem to be doing anything, so we could either try and stabilize the input voltage, the input power rail, by connecting it to the positive rail, whichever one that happens to be. Otherwise, we could take it out and it would have absolutely no effect in this occasion. But anyway, I think that was a fun little project, and I hope you enjoyed it as much as I did, and I hope to see you in the next video.